I welcome to all the students to this class. Today we will be solving few more problems on the acceleration analysis of the mechanism. As far as today's topic is concerned, today's questions are concerned, today's questions will be based on finding the acceleration using acceleration of rigid bodies using the acceleration equation. Let me introduce you to this mechanism as given in example 16.17. If you look at this mechanism is known as, this is called uh, 4-bar linkage or 4-bar mechanism. Very, very important and very famous mechanism in mechanical engineering. This is called 4-bar mechanism. As far as a 4-bar mechanism is concerned, 4-bar mechanism, this is also known as, this mechanism is also known as, you can call this also as, this is also known as slider crank mechanism. Very famous mechanism. We also call this as slider crank mechanism. Slider crank mechanism. As far as the slider crank is concerned, why we call this a slider crank? This is called slider crank because if you look at link AB, if you look at this link AB or rod AB, this rod AB undergoes the complete 360-degree rotation. Okay, it rotates 360-degree angle. As far as the rod BC is concerned, the rod BC pushes this slider up and down. Slider goes up and down. Okay, this C slider, it goes up or it goes down. This is called a slider. Okay, and the link AB which rotates complete 360 degree, this is called a crank. This is called crank and this is called slider. Okay, you will be learning about the slider crank mechanism in your theory of machines in your third semester. This is a very important mechanism based, and it's the fundamental basis of, it forms the fundamental basis of the working of an IC, internal combustion engines. Now let's see what the question asks us. The question is the crankshaft AB. We have the crankshaft AB, link AB turns clockwise. It turns clockwise. Link AB is turning clockwise. It's rotating clockwise with an angular acceleration of 20 radian per second square. The magnitude of its angular acceleration is 20 radian per second square. See, if you curl your fingers in the direction of the given arrow, the thumb will go inside. Okay, the direction of the thumb will be inside. Okay, so if we treat this to be our x-axis and we treat this to be our y-axis and we treat this to be our z-axis, then as far as the direction of the angular acceleration is concerned, the angular acceleration is in negative z direction, minus k direction. Same is the case with omega AB. Now it says determine the position, determine the acceleration of the piston at the instant AB is in the position shown. Now we have to find what is the acceleration of the piston. Piston is C. Okay, as far as link C is concerned, C is called piston. Okay, we have to find the acceleration of C. At this instant, as far as omega AB is concerned, the angular velocity of the rod AB is given as 10 radian per second. It is 10 radian per second. And angular velocity of rod BC, the angular velocity of rod BC is given to us as 2.43 radian per second, and it's anti-clockwise. It's given to us. Okay, we are given parameters. We have to find the acceleration of C. Okay, in order to find the acceleration of C, what we will be doing, we will be locating a point. We will be locating a point adjacent to the point C. That is, um, we have to draw the vector to point C from an adjacent point. That is, we will be drawing the vector to point C from point B. The vector will be like this. Okay, so we can write the acceleration of C in terms of acceleration of B. So equation for us will be, we will be having acceleration of C in terms of acceleration of B. So in order to find the acceleration of C, we should be knowing what is the translational acceleration of B, but translational acceleration of B is not given to us. So first and foremost thing is that we have to find the acceleration of B first. Okay, so what we will be doing, what we will do, we will first find the acceleration of B. In order to find the acceleration of B, what we will do, we will draw the vector from A to B. Okay, and we write the acceleration of B in terms of the acceleration of A. So we can write in between the points A and B, we can write acceleration of B is equal to acceleration of A is equal to acceleration of A, translational acceleration of A, plus angular acceleration alpha angular acceleration of AB, I will write this as alpha AB, angular acceleration of AB, angular acceleration of B, cross product with radius vector from A to B, that is RAB. Radius vector from AB will be RAB vector, okay? And minus omega square, omega angular velocity of AB, angular velocity of AB square, omega AB square, and RAB vector. It's like this, RAB vector. Okay, so this is how it will be writing. Now we know as far as acceleration of B, we have to find it out. As far as acceleration of A is concerned, look at the acceleration of A. As far as point A is concerned, the point A is fixed. Point A does not translate. Point A has no motion at all. It does not translate along x-axis, neither y-axis, neither z-axis, okay? So it does not have a motion at all. Therefore, acceleration of point A will be equal to 0. Now, angular acceleration of AB. Angular acceleration of AB is given to us. It is 20 radian per second square. But it is clockwise. If you curl your fingers in the direction of this arrow, the thumb will be along minus k direction. So we'll write its magnitude is minus 20 k cap. So it is minus 20 k cap. Cross product with RAB. Now we have the radius vector from A to B. Okay. Now, as far as the radius vector from A to B is concerned, we will be resolving this vector. This vector AB will have two components. One component will be in this direction, and its another component will be in this direction. Okay. As far as this component is concerned, this component will be RAB cos of 45, because this angle is 45. This angle will also be equal to 45, but this is along minus I axis. So it is, we'll write this as, this is RAB. RAB can be written as, this is RAB vector. I think we are given the magnitude of this RAB. It is 0.25. So it will be, this component will be 0.25. It will, but it will be minus because it's along negative x-axis. We'll write this as minus 0.25 cos 45. Okay, so minus 0.25 cos of 45 degree I cap. Okay, so this is our I component, and its y component will be, this is plus 0.25 sine 45 j cap, 0.25 sine of 45 degree j cap. This is its another component, and minus omega square. How much is the angular velocity of the rod AB? If we talk about the angular velocity of the rod AB, the angular velocity of the rod is 10 radian per second, and it's also clockwise. So we'll write this as, it is, we have to find the magnitude only. So it is 10 radian square. So it is 10 square, radius RAB, and we have to take RAB vector. RAB vector we will write as, it is minus 0.25 cos 45 I cap, cos of 45 degree I cap, plus 0.25 sine of 45 I cap, 0.25 sine of 45 j cap, sine of 45 j cap. Okay, so this is it. So let's solve it. Once we try to solve it, it will be, so it is, first of all we have minus 20, and the different components it has are like, have first component is minus 20 component. So it's minus 20 into 2.5. So that's equal to 50, 25 into 2.25. So minus will be plus. So it will be 20 into 0.25. That comes out equal to, that is 20 multiplied by 0.25 is equal to 5. So this is equal to 5. So this is 5. Now we have k cross I. Okay, and we have this cos 45. Cos 45 is equal to under root 2. So it will be 5 by under root 2. Okay, now we have k cross I. We know I, j cap, and k cap. Now we have k cross I. As far as k cross I is concerned, k cross I is equal to j. So it will be minus is plus, k cross I is equal to j cap. So it is 5 by under root 2 j cap. And we have again, then we have k cross j. As far as k cross j is concerned, k cross j is minus I. That is this, k cross j is equal to minus I. Minus will become plus. So it is plus 20 into 0.25. 20 into 0.25 is 5. by, and then we have sine 45, that is under root 2, sine by 45 under root 2, k cross j is I cap minus I cap. Okay, so this is it. So this is the value of, we have solved this. Then we have minus, this is 100 into 0.25 is 25, so it will be 25, but this is minus, this is minus, minus will become plus, so this is 25, cos 45 is under root 2, under root 2, and you have your I cap. Okay, so this is our I cap. So minus plus is minus, so this is minus, so it is 25, sine 45 is under root 2, so it is 25 by under root 2, and we have our j cap. Okay, so this is it. So let's solve this. So we can write this as acceleration of b, we are getting as acceleration of point b, we are getting as this is 5 under root 2 I cap, and this is plus 25 by under root 2 I cap, so it is 30 by under root 2 I cap. So it is 30 by under root 2 I cap. This is acceleration of b, comes out equal to 30 by under root 2 I cap, and minus, it is 25 minus 5 is 20, so that is 20 by under root 2, that is 20 by under root 2 j cap. Okay, so this is the acceleration of our point b. We are done with the acceleration of point b. So now we know the acceleration of point b. We can know the acceleration of point c in terms of the acceleration of point a. So what we will be doing, let's rub this out. We can therefore write this as, therefore we write now acceleration of point b can now be written as, we can now therefore write acceleration of point b, acceleration of point c in terms of acceleration of point b. So we'll draw a vector from b to c. Okay, and we write the equation as acceleration of point c is equal to acceleration of point b, acceleration of point b plus angular acceleration of bc, that is alpha bc, alpha bc cross rbc, cross rbc, radius vector from b to c, minus omega square, omega of what? Omega of bc, that is omega bc square, cross multiplied by radius vector from b to c, that will be rbc vector. Okay, so we can substitute the values. As far as the acceleration of b is concerned, acceleration of b is 30 by under root 2, 30 by under root 2. You can write this as, this is 21.21. Okay, so this is 21.21, this is 21.21 I cap, minus we have 20 by 20 by under root 2, 20 divided by under root 2 comes out equal to 14.14. So this is 14.14 j cap. This is acceleration of b. Okay, then we have angular acceleration of bc. As far as angular acceleration of bc is concerned, angular acceleration of bc is, it is anti-clockwise. If we curl our fingers in the direction of the arrow, the thumb comes along positive z direction, so it will be, it is 2 point, as far as alpha is concerned, angular acceleration of bc is concerned, the angular acceleration of bc is not known to us. Okay, the angular acceleration of bc is not, we are given only the angular velocity, it doesn't matter, so we'll write alpha bc. So we are not, we don't know the value of alpha, so angular acceleration we don't know, but it's rotating clockwise, so it has to be along that direction. We write alpha bc k cap, cross product with radius vector from b to c. Now as we went on to find the radius vector from b to c, okay, so radius vector from b to c is like this, so this needs to be resolved. How we can resolve this rbc? We can write this as, this rbc can be written as, this rbc can be resolved in this direction, in this direction. It will have one component like this, another component will be like this. Okay, so the total length is 0.75. If you look at the angles, since this angle is already given to us, this is 13.6 degree. Okay, so we know as far as the angle given to us is, this angle is already given to us, this is 13.6 degree. Okay, now this angle is 90 degree, therefore we can find out this angle. Okay, this angle will be 90 plus 13.6 minus 180, that comes out equal 90 minus 13.6, that is 76.4. This angle is 76.4. Okay, this is 76.4 degree, therefore its x component will be 0.75, 0.75 cos of 76.4 I cap, and the j component will be plus 0.75 sine of 76.4 sine of 76.4 j cap. Okay, so this is RBC. Then we have omega BC minus, as far as omega magnitude is concerned, that is 2.43, that will be 2.43 square, 2.43 square multiplied by RBC. RBC is this, we have to write this vector here, that is 0.75 cos of 76.4 I cap, cos of 76.4 I cap plus 0.75 sine of 76.4 sine of 76.4 j cap. Okay, so this is our I and j component. So we are done with this. Now we can solve this equation. This equation is as we have solved the previous equation. So it's not a too complicated equation now. We can simply solve this equation to obtain the values of acceleration of c and omega p. Now see, as far as c is concerned, as this crank AB rotates in clockwise direction, this link BC will be pushed forward. As a result, this C will go upwards. So as far as the acceleration of C is concerned, acceleration of C will be along up direction, that is along J direction. Therefore, you can write this equation as, you can write this acceleration of C is along J cap. So it is AC J cap will be equal to, it is 21.14 I cap minus 14.14 j cap. Then we can balance the components to obtain the values. It's not a big deal now. So then, and again we have the components, alpha BC will be taken as alpha BC. So it is K cross I, as far as K cross I is concerned, that is J. So this is plus 0.75 into alpha BC, we have to find it, cos of 76.4, K cross I is J, cos of 76.4 degree, and K cross I is equal to J. Okay, this is here. Then they have K cross J. K cross J is minus I, so it is minus 0.75 minus 0.75 alpha BC sine of 76.4 K cross J is minus I, that's I here, and minus is here. We are done. And the last terms, you can write this as this 2.43 square, 2.43 square, 2.43 square multiplied by 0.75, and this 0.75, we can 0.75 cos of 76.4 I cap, cos of 76.4 I cap plus 0.75 sine of 76.4 sine of 76.4 j cap. Okay, so we are done with this. Now the second step, which the students will be performing themselves, will be summing up all the I components. Write all the I components together. Okay, and write all the j components together. I components and j components are to be written together. Okay, then as far as I component on the left hand side is concerned, there is no I component on the left side, therefore all the I components on the right hand side should be equal to 0. Okay, so once you do it, and the value of the j components should be equal to AC. Okay, so from this equation we will obtain the value of alpha BC, and from this we will obtain the value of acceleration of point C. These steps I'm leaving to the students to do them themselves. There's a little modification. The I components are not equal to sorry. As far as the j components are concerned, your j components are not equal to 0, but your I components are equal to 0 because there is no I component on the left hand side. Let's take the problems from the unsolved section. We have the preliminary problem 16.3. It says, set up the relative acceleration equation between points A and B. We have to set up the relative acceleration equation, okay? What we have to do, we just have to write the equation between points A and B. We don't have to solve the equation. That is the question that is given to us. Look here in the problem number A. We are given that the acceleration of point A is given to us, okay? We have point A here, point B is here, okay? The velocity of point A is given to us. The acceleration of point A is given to us. But neither we are given the velocity of point B, nor we are given the acceleration of point B. Okay, so what the trend should be? The trend is that we have to solve for the acceleration of point B in terms of the acceleration of point A. So we'll be drawing the vector from A to B. Okay, so now as you write the acceleration equation for points B and A, you will write acceleration of B is equal to acceleration of A plus angular acceleration of the rod or the link joining A and B, that is alpha AB, and its cross product with the radius RAB, radius vector from A to B, minus angular velocity square of the rod AB and multiplication with RAB vector. This is what you have to do. This is called writing the acceleration equation between the 2 points, and this much we have to do. We don't have to solve it. We have to set up the equation on it. Okay. Same is the problem A and B. We are given the acceleration of B. Okay, A. We have to find the acceleration of B. We have to write the acceleration equation between B and A. Okay. So in this way, the way we have written this equation, I want students to write it for this mechanism, for this mechanism, for this mechanism. For all the mechanisms, the students should be in a position to write the velocity acceleration equation between the 2 points. Same is the case, like you have point B and point A and point B. Okay, you have to write the velocity equation, acceleration equation between points A and B. Okay, so what we will be doing, that is, we have to find the acceleration of B in terms of the acceleration of A. We have to write the acceleration equation of point B in terms of the acceleration equation of point A. But point A is itself attached with some point. Let's call this as point O. So first equation will be, we'll be writing acceleration of A in terms of acceleration of O. Then we will be writing acceleration of B in terms of acceleration of O. A. That is, first equation will be acceleration of A is equal to acceleration of O plus angular acceleration of OA. So we'll write this as alpha OA vector cross radius vector from O to A. We'll write this as ROA vector minus angular velocity square of OA, that is omega OA cross radius vector from O to A. Sorry, multiply, not cross. This is one equation, okay? So this gives us the acceleration of A. Then we have acceleration of B in terms of A. That's it. That's easy. So acceleration of B will be equal acceleration of A plus angular acceleration of OA, angular acceleration of AB, angular acceleration of AB cross radius from A to B, RAB, minus angular velocity of AB, that is omega AB square, and a radius vector from A to B. That is it. Since we are given angular velocity of OA is 0, therefore this term is 0. You will get acceleration of A in terms of, so we can write this as acceleration of B will be equal to acceleration of A, that is equal acceleration of O plus angular acceleration of OA vector, angular acceleration of OA cross ROA cross ROA. That's like this, cross ROA minus omega square minus omega square OA multiplied by ROA vector. That's it. So this is our acceleration of A. Then we have plus angular acceleration of AB, that is alpha AB, cross radius vector from AB, that is RAB. That's it. This is the equation for acceleration. Okay. This gives the acceleration equation between point B and point A. This is what you have to write. Okay. So in the same way, you write about point B and point A. So I request my students to write the acceleration equation between all these points. Now let's go to the fundamental problem section. Okay, let's try to solve a few more questions from the fundamental section. And then hopefully we will be going to the relative velocity analysis. Then at the end, we have to solve instantaneous center of zero velocity. That's very important, a brief topic. So in the next class, we'll be talking about a few more equations, few more problems we'll be solving based on the acceleration analysis. Thank you very much.